Well, ahoy there, mateys. We are jumping into 5.3, which is all about rates and unit rates. This is basically just an extension of ratios. So ratios normally compare two of similar items, and rates will often compare two different quantities. So like miles per hour. So you can compare things that are not necessarily the same. Those are generally known as rates. So here we have some definitions that they're listing out for us. So a rate is a ratio of two quantities using different units. And then a unit rate, that's a very important type of rate. A unit rate compares a quantity to one unit of another quantity. So that could be like beats per minute or miles per hour or degrees per second. So that is a unit rate. And then equivalent rates have the same rate. So that's the same as equivalent ratios, basically. So for example, if you pay $27 for 3 pizzas, the unit rate is $9 for 1 pizza. So unit rate is just figuring out how much the ratio is when one of the numbers is 1. All right, so this might be a quick, nice little thing to take some notes on before we jump in to using rates. So here's our first example. Let me move myself. Whee! All right. So you're going to see a lot of double number lines as you're working through 5.3. So the double number line shows a rate at which you earn points for successfully hitting notes in a music video game. Write a rate that represents this situation. So the top arrow, this top line on the double number line shows you points, and then the bottom part is the notes, and it shows the corresponding points to notes. So what is one possible ratio, or rate in this case, because they're different units, could you write for this number line? All right, so 600 points to 4 notes is one of the rates that you could write. So all of these are rates. So the 750 to 5 is a rate, 450 points to 3 notes is a rate. What is the unit rate for this situation? Okay, so in this case, the unit rate is the number of points per 1 note, and that is this 150 points per 1 note. Okay, so all of these are rates, but the unit rate is this one where the number of notes is 1. Okay, so now we're going to do some more of these examples here. Let me shrink myself. Whee! Alrighty, so this first one, take a look at this. What is a rate that you could come up with here for number 1? Okay, so you could have said like 45 to 3 or 60 to 4 or $30 to 2 hours. However, I didn't give you those options. So the only option on here was $15 per hour. This also happens to be the unit rate. So $15 per hour is the unit rate for this first one. Okay, so for number 2, it gives you a possible rate of 220 miles in 4 hours. I want you, for number 2, to find the unit rate. So what is the unit rate for number 2? Okay, so this one doesn't even show the 1 on here, but if you were to cut each of these in half, it would be 55 miles in 1 hour, or 55 miles per hour is the unit rate for number 2. Okay, so for number 3, it gives you an example rate here of 15 feet per 3 seconds. What is the unit rate for number 3? Okay, the unit rate would be 5 feet per 1 second, or 5 feet per second. And for number 4 here, one possible rate would be 24 degrees in 6 hours. What is the unit rate? Okay, and again, this one doesn't show it on here, but if you were to cut this down to 1 hour, you would find it's 4 degrees in 1 hour. That's the same as 24 degrees in 6 hours. All right, so we're going to do a lot of stuff with rates and unit rates. Some of the problems will be like word problems like this one. And we're going to revisit how to use ratio tables to solve rates and unit rates. Because again, a rate is just a ratio, but with different units. So a piece of space junk travels 5 miles in 8 seconds. How far does it travel per second? So what is the unit rate for this one? So go ahead and try and solve this however you want to solve it, and then we'll go through how to solve it with a table. Okay, so one way is to create this little table here. You start by saying 5 miles in 8 seconds. That's our first part of this table. But we want the miles per 1 second, so this 8 needs to change into a 1. So again, using ratio tables, you, in my opinion, want to use basically just multiplication and division. Don't try adding and subtracting. So here you would divide this 8 by 8 to get 1, which means you also have to divide the 5 by 8 to get 5/8. So it travels 5/8 miles every 1 second. That is the unit rate, 5/8 miles per second. Okay, and we got one more example. Okay, a chef buys 6 pounds of salmon fillets for $51. How much will the chef pay for 9 more pounds of salmon fillets? So again, you can use a table. I want you to use whatever strategy you want to solve this problem. Okay, let's go over how to solve this again with a ratio table. So start by putting the dollars and pounds. It's $51 for 6 pounds. And you could have those inverted, that's fine. But the main thing you want to do is find the unit rate. You want to figure out how many dollars per pound. So if it's $51 for 6 pounds, you can divide them each by 6. And it tells you it's 8.5 or $8.50 per pound. Okay, so now that you know the unit rate is $8.50 per pound, you would then multiply that by 9. Okay, which means you're also going to multiply the 8.5 or the 850 times 9 and find out it's $76.50 for 9 pounds. So the main trick is here, take the original ratio rate that they give you, figure out the price per pound first, then you can apply that unit rate to as many pounds of salmon as you want. All right, so now you buy, you also like tilapia, apparently. So you buy 2 pounds of tilapia fillets for $16. What is the cost for 7 pounds of tilapia? So what I want you to do first, I want you to find the unit rate for the tilapia. Okay, so if you did $16 divided by 2 pounds to get $8 per pound, that is the unit rate. So then what would it cost for 7 pounds of tilapia? All right, so 7 times 8 is 56. They're showing you how to use a number line, a double number line. You can also use a ratio table. You can also use a double number line to solve this. So it's $16 for 2 pounds right there. So it would be $32 for 4 pounds, $48 for 6 pounds, $64 for 8 pounds, and then 7 pounds would be right in between the 6 and the 8, and 56 is right in between 48 and 64. So that's how you can use a double number line. My suggestion is find the unit rate first, the $8 per 1 pound, multiply by 7, and that takes you right to the answer. Okay, so as you're working through 5.3, it's all about rates. They're basically the same as ratios, except they use different units of measure. If you need any help or have any questions, see me. Send me an email, send me a Flipgrid question, or see Mrs. Rude during her on-demand hours. Good luck, and I will see you during our next live session. Arr!